Okay, this is for the crunchy case people. You can see a lot about which is on crunchycase.com. Yesterday, I was talking to a really sharp newspaper reporter, and he had this question: is like, as this quarantine happens, and you have a reduced amount of ozone pollution that's either from cars or a result of cars, can you more easily trace the ozone pollution from the factories? How much of a contribution are they making to to the contents of our air? How much ground level ozone is coming from them? And can we find out something during this quarantine that can potentially help industry put out less ozone or put out less volatile organic compounds and nitrogen oxygen compounds that lead to ozone, and perhaps even save money in their process? I know that people say, oh, you can't work cleaner and cheaper. That's not possible. I think it's possible. I think it's possible. And the research from particulates suggests that it's actually way smarter, as far as the quality of our air, to have a more efficient combustion process in the first place than it is to try to catch the horses after they run out the gate, try to clean the pollutants after you've already burned the stuff. It actually saves money and it helps the air more by controlling the production process rather than the pollution process. There's a lot of mathematical reasons for that. It's a beautiful, beautiful piece of work, I think, but I did it, so it's my work. Of course, I'm going to find it beautiful. We don't find our children ugly, even when they are, but they never are ugly. They're always beautiful. Okay. However, he asked about ozone. So ozone's an interesting pollutant because it's relatively easy to measure. It's really damaging on our lungs. It's actually by either the surface area quantity or the volume. I think the volume might question. It might even be the volume. It's the second most populous pollutant in our air behind particulate matter. So it's a major pollutant, and in some ways it may be more dangerous because it's corrosive and reactive to our lung tissue. Well, after speaking with this reporter, it seemed like there may be an opportunity to and by the way, the reporter's name, I'll put the link to the reporter. His name is Chase Woodruff. I'll put the link down in the little connection thing there. There may be an opportunity to crowdsource some of these pollutant measurements. There will be people say that you can't crowdsource scientific measurements, and on some level they are completely correct, because the integrity and the quality of a measurement the integrity and quality of a measurement that you can get out of a simple little device is generally not the same as something you get out of laboratory equipment. But as an additional layer, it's outstanding, because when you crowdsource a measurement and you're increasing the resolution, not necessarily with the precision of the device, but spatially. So having 100 testers in this country and 100 testers in that country and 100 testers in that country, that's a form of crowdsourcing that we've actually been using for a long, long time, as far as temperature and pan, they call it pan collection rate. So the amount of rainfall that falls in a certain dimension pan. And these things are calibrated. And it's a wonderful way of actually getting really usable data. So it turns out when you get all these disparate data sources and you calibrate them against laboratory grade equipment, they're actually, the measurements are actually very useful, surprisingly. So all right. So I'll getting to that. So there's an opportunity to crowdsource the ozone measurement. So these are corrosive gases that you breathe into your lungs. There's an opportunity to crowdsource that. So I spent last night, I am fortunate enough to have an ozone machine. So the stuff you least want to breathe, my dad, who's a World War II veteran and lived to 95 years old and only died last year, loved to breathe ozone. I said, you don't understand, it's corrosive to your lungs. He said, oh, give me that shit. It's fine. So he had 2 ozone machines. I finally got him off the industrial ozone machine, and he started using the like a smaller ozone machine. It doesn't produce nearly as much ozone as the industrial one. But I set up a little experiment in a closet. I sealed the bottoms. I wouldn't get as little of the ozone gas as I could. And I tested some different things. Okay. I will show all this to you where there's going to be an experiment video, and there's going to be an opportunity for everybody who wants to contribute to this global ozone research project for about $1 at most, $1 worth of research equipment. And I may work something out where I can send you guys some of the kits. And if there's enough people doing it that I can't even send them out anymore, it'll just be, I designed it so that it's stuff that you already have in your house. You shouldn't need to go buy anything. It's a rather simple but surprisingly subtle way of measuring the ozone in the air where you are. And if you're near a roadway, that's incredibly valuable data. And if you're away from a roadway and you're, say, in the middle of a forest, that's incredibly valuable data. Because the person who's near the roadway should see a major reduction in their ozone due to the lack of cars, and likely they will see that. Or the person that's downwind from a factory may not see as much because the factory hasn't necessarily been running at a reduced capacity. Or how much of this ozone travels through the air? How much does the wind push it? How much does it react to the particulates that are already in the air? That's an open question. Ozone's a weird pollutant because pollution is, I mean, in a way, it's a lot like coronavirus. Coronavirus is something people are paying attention to because it's an odd virus. It doesn't really impact children as much as it does, and it doesn't really impact the very, very elderly as much as it impacts a certain age population. And this has got people's attention. Well, it's very similar with ozone. It's an odd pollutant because most of the time with pollutants, you're in more danger when you're near a smoky factory, when you're near a bunch of cars, when you're near a source of pollutants. If you're working around wood fires a lot, you're going to get more particulates into your lungs. But ozone is an odd one because in some research suggests that it's actually more dangerous in some suburbs than it is in the inner city because the particulate sources that react with the ozone in the air are deficient in the suburbs. And so where does it react? Inside the lungs. So if you can get it to react with an air pollutant particle that's relatively non-harmful, say a PM10 that makes the air look ugly, it's unfortunate, but you see PM10s, but they're not nearly as dangerous to us as PM2.5s because PM2.5s penetrate into our lungs. They're so small in some cases that they can pass through the blood barrier. They're so small that they impact with the feature length of the alveoli. They impact with the way that we extract oxygen out of the air. So ozone's one of these odd ones, and it's very much like coronavirus in that way, in that it doesn't even affect, in some cases, as a lot of research suggests, it doesn't impact people who live near pollutant sources as much as it does people who live in relatively clean areas. So you can live out in, I'm going to use an extreme example here, and I apologize for that, but it illustrates the concept. You could live in a beautiful, pristine pine forest in Georgia, far away from any factories, or a beautiful, pristine pine forest in Estonia, far away from, not necessarily pine, but a similar softwood tree like pine. I don't know what kind of trees they have in Estonia. And you could be getting more lung damaging ozone pollutants, ground level ozone, in that remote and relatively clean area than somebody might get living right next to a factory. And that's the really scary part, because as people stop smoking, we're finding that there's new sources of lung cancer that were kind of being covered up before. We didn't notice them because people were smoking so much. And now we're finding out, well, yeah, radon's a huge source of lung cancer, but there's other sources too. And there's been research that links ozone in the air to significant lung damage. The kind of lung damage that kills, what is it? About 750,000 children a year in developing nations. A significant source of misery in this world that we have the potential to fix. So stay tuned. Okay. There will be another video, and you guys are going to be like, oh, that is a really simple method. And it is a really simple method, but it's something that I had heard somebody mention probably 25 years ago, and it just stuck in my head. And when I ran on researched it online, I I actually did some research online, and I couldn't find anybody else who's done this kind of research about how to measure simply, easily measure ozone pollution next to your house, next to the road, next to a factory. If you live near a factory, or if you have a if you live out of your van, you could even do this experiment. It's just so dead simple. It's remarkable. And in a way, it's also very illustrative of how ozone damages healthy lung tissue. Because in using rubber is in a sense a natural. I'm gonna have to go. All right. Okay. Stay tuned. It's gonna be a really good experiment.